Okay, today we're going to look at the last section of Chapter 8 here is looking at solving rational equations and inequalities. This first problem here says a music download service advertises downloads for $1 per song. The service also charges a monthly access fee of $15. If a customer downloads songs in 1 month, the bill in dollars will be what this equation is here. So the actual cost per song would be 15 plus x over x, where x would be the amount of songs. So they want to know for this question, how many songs a person would need to download to make the actual cost $1.25. Okay, well, if this is the actual cost per song and we want it to be $1.25, we should set those two things equal to each other. And if we solve this out, we should get the answer for this problem. Well, if we're going to solve something like this, what we need to do is get it so that it is not any fraction anymore. We don't want a problem that's a fraction. So what we want to do is get rid of this x that's on the bottom. And how we can do that is by undoing division, and you undo division by multiplying. So if we multiply both sides by x, now we should be able to solve this out. So we have 1.25x equals, these would cancel. Now we have a linear equation we can solve. At this point, we'd want to get all our x's together, so we'd want to minus an x from both sides. Now, when we're minusing this x, it'll cancel on this side. What we're subtracting here is an x. If there's no coefficient in front of that, we know it's 1. So if we take 1.25 minus 1, we would get 0.25. X equals 15. Now the last step would be to divide by 0.25, and by doing that you would find out that it would take 60 songs to bring the actual cost per song down to $1.25. So the 60 songs would take that $15 access fee and kind of split it over all those songs and bring the cost down. All right, so those types of problems where you are solving an equation and it involves rational equations is the problems we're going to be looking at today. So a rational equation, any equation that contains one or more rational expressions. Rational equation is one that contains one or more rational expressions. So the point of these problems is what we're going to try to do is figure out and solve rational expressions that are equal to each other. All right, so let's look at an example. Number 2 here. We want to be able to solve this problem out. In order to do a problem like this now, we can't just times by the bottom like we did in the first problem, because now we have two things here being added on this side and another thing on this side. Our goal is to get, in these problems, a common denominator, just like you did in previous worksheets. So let's try to figure out what our common denominator is going to be here. It looks like we're going to need a z plus 2 in all these terms. So all these are going to need to get a z plus 2. Same with this first one, needs a z plus 2. But we also have some numbers here. We have 28 and 4. We want to figure out what is the lowest common multiple of 28 and 4. Well, 4 does go into 28. So 28 appears to be the least common multiple. So we want a 28 with all these 2. So 28 times z plus 2 looks like our common denominator. So this needs to get multiplied by 28. And 4 times 7 will also give us 28. Now whatever we multiply on these to the bottom, we also need to make sure we multiply on top. So here we need to multiply by z plus 2. Here we need to multiply by 28. And here we need to multiply both by 7 and z plus 2. Okay, I'm going to write that all a little bit bigger so it's easier to see. So we got 9 times z plus 2 plus 3 times 28 equals 3 times 7 times z plus 2. On the bottom now, all these should be the same denominator of 28 times z plus 2. All right, so that's a good start. Now we got a common denominator, and if we got a common denominator, what we could do here is add these two on the left together. These two terms should be able to be added since they have a common denominator now. So if we add them up, it's basically the same thing now with just that same common denominator. So the whole denominator here would be z 28 times z plus 2. All right, so we got this going here, and we're doing pretty good. Now we got the same stuff on bottom on both sides here and here. What we could do is now, like we did on the first problem, and cross multiply. Now here's the thing: if we did some cross multiplying, which we could, or we could multiply both sides by 28 z plus 2. We can multiply the other side by 28 z plus 2. Well, what's going to happen if we do that? Well, this would cancel, and this would cancel. So really, all we need to solve now that we had the common denominator is what's on top. Because if we multiply by that common denominator, it cancels out. So now the whole problem just becomes solving what we had in the numerators. So we just got to solve this out. And that's not too hard to do. We should be able to solve that. That's just an algebra equation. Distribute. If we do 3 times 28, that's going to be 84. 3 times 7 is 21, so we're going to need to distribute 21 to both. 21 times z is 21z. 21 times 2 is 42. Now combine like terms. And if we solve this out using just getting our z's together and getting our x's together, we come up with the answer of z equals 5. So that's the solution. Now, when you get a solution on these, the only thing you want to do is make sure, if you go back to the original equation, that this actually works. And the only way this answer wouldn't work would be if we would plug it in for z right here, and we'd get division by 0. So if we put our answer of 5 in there, 5 plus 2 is 7, we're okay. We wouldn't get any division by 0. So 5 is, in fact, the answer for number 2. All right, let's try another one of these. Number 3 wants us to do the same thing. So we want to get a common denominator. Looks like here, again, we need x minus 2 on all these. And then we want to figure out what's the least common multiple of 2 and 6. Well, 2 does go into 6, so it looks like 6 is. So this needs to get times by 6. And then 2 needs to get multiplied by 3 to be 6. So the whatever we multiply on bottoms, we got to multiply on top. Once you get the same denominator on all these, we're okay. All these denominators now should be 6 times x minus 2. So all we need to focus on now is solving the top. What are you going to get when you solve this out? So if we solve the numerator, we should get the answer. If we distribute, you get 5x minus 10 plus 12 equals 1 times 3 is 3, so we got to distribute 3. 3x minus 6. Keep solving now. And looks like we get an answer of -4. Now, again, when you're done, just make sure, does -4 actually work out? If we put -4 back in for x, we'd be okay? Yeah, that should work out. If you actually did that and solve the problem out, now both sides would be equal. All right. Let's look at another one here. If we were to try to do this one, same thing. Try to get a common denominator. So on this one, looks like this first term would need to get multiplied by x minus 4. Same with the last one. Now we got to figure out what's the least common multiple of 12 and 48. Well, 12 goes into 48, so 48 would be it. So we got to multiply this by 48. And same with the first one, we need 48. It's already 12, so this would need to get times by 4. All right. If we do this now, if all these are the same, we talked about before, if you multiply through, all these would then cancel out. So we just need to solve the top. And then again, this is just some algebra. So if we solve this algebra out, we probably want to multiply these first two numbers and get 28 before we distribute it. And then it would be trying to figure out what the rest of it is. So do the distributing and solve. And if you solve it out correctly, this one should be 20. So 20 would be the answer. All right, there's one more of these. Why don't you pause it quick, try this last one out, see if you can do this last one. So pause it now, pause the video, try the problem. All right, if you did this one correctly, you should have gotten a common denominator of 24 times 3 minus x would be the common denominator. So if you did all the correct multiplying and solved it out, this one should have came out to be negative 45 for the answer. And negative 45 is an okay answer. If you put that in for x, we're okay. All right, flip to the back of your note sheet. On the back, we're going to look at some other problems that have these rational expressions. And this one wants us to solve another problem where you got a fraction equal to a fraction. Goal, again, is to get a common denominator. Now, when you start getting some of these where you see pluses and minuses, our first job is to factor it out. So on number 6 here, we want to factor anything we can. R squared minus 5 doesn't factor because 5 is not a perfect square. This one does. This one's a difference of squares. On the last one, see if we can do any factoring. The top, I don't think there is anything that multiplies to 2 and adds to 1, so that doesn't factor. So it looks like only one thing factored there. So what we want to do is looking at the bottom stuff, what is the common denominator going to be? Looks like r plus 1 times r minus 1, the denominator of the middle is our common denominator. So this needs to get multiplied by r minus 1. So the top needs to get multiplied by r minus 1. We're going to have to multiply all this stuff then by r minus 1. Our first term doesn't have a denominator, so that one's going to have to get multiplied by both r plus 1 and r minus 1. So whatever we multiply, put on the bottom, we also need to multiply to the top. All right, now that, just like the problems on the front, now that we have the same thing all the way across, if we were to multiply by all these denominators would drop out. Our goal is to solve the top. What's this top going to be equal to? Well, we want to see what do we get when we multiply all this stuff together. So this is the problem we now need to solve. Okay, so this looks like a lot of just algebra and multiplying and distributing we have to do. So on the first one here, we got to multiply r plus 1 times r minus 1. We know from before that comes out to be r squared minus 1. On this side, this is a lot of distributing we're going to need to do here. So start out by multiplying r squared times both of them, then r times both of them, then finally 2 times both of them. If we do that, we get r cubed minus r squared. Then multiply r to both of them plus r squared minus r, 2 to both of them, and you get that. There's one last distributing we need to do over here, and this is what our problem becomes. So now we got to see how do we simplify this down, and hopefully we can find some stuff that would cancel out or simplify? And I think we do. If we got an r cubed on both sides, if we subtract that, it should cancel out on both sides. We have two terms right here, minus r squared plus r squared. That would cancel out. That would equal 0. We have a minus r here, so if we were to add r to both sides, those would cancel out. So right off the bat, we see a lot of stuff drop out of this problem. So now our problem ends up being r squared minus 5 equals 2r minus 2. We got to solve that out. This one's not as easy as some of the ones on the front because this we can't just solve with easy algebra. It is a quadratic. We have a degree 1 equation and or term and a degree 2 term. This is a quadratic. Quadratic problems, if you want to solve them, you need to get everything to the same side. So we should minus 2r and add 2 here to both sides so that we get it equal to 0. So now we have r squared minus 2r. Negative 5 plus 2 is going to be negative 3. Looks like we need to do some factoring. What's going to multiply to negative 3 and add to 2? Negative 3 and positive 1. So we get r minus 3 times r plus 1 equals 0. Setting those both equal to 0, we get that r equals 3 or r equals negative 1. Those are the two solutions. Now remember before we said on the problems on the front, those are solutions as long as they work with the actual answers up top. So let's see, does both 3 and negative 1 work? Let's test 3 first. If we were to put 3 in for r, is our denominator going to be okay? Yeah, if we add these up, that's 4. If we do this, 3 squared is 9 minus 8, that would be 8. 3 looks like a good answer. So one solution to this problem is 3. Let's check negative 1. If we put negative 1 in, does it work? Well, let's see. Negative 1 plus 1 equals 0. Ooh, remember how we talked about can you divide by 0? No. R equals negative 1 is not a solution. That's what's called an extraneous solution. And an extraneous solution is one that is created by multiplying by the least common denominator, but it's not an actual solution to the original problem. So the only answer on this one would be 3. Negative 1 is an extraneous solution. All right, let's try another one here. Let's look at number 7. We want to do the same thing on this one now. So check, is there any factoring to do first? With the first one, no. Second one, no. Third one, yes. We want to factor this. This denominator is a difference of squares. It's the same as x plus 1 times x minus 1. So now we want to get common denominator throughout the problem. Looks like the first one needs to get multiplied by x minus 1, so we need to multiply that to the top. The middle one needs to get multiplied by x plus 1, so we need to multiply that to the top. Now if we were to multiply through, all our denominators should cancel out. We need to solve the top. So here's what the top of the problem becomes. This minus, we're subtracting these two terms, equals, we got an equals sign here and a minus sign here, negative 2. If we solve that out, that should tell us our solution. Well, we got to distribute. We got to distribute here. Now, be careful on the second one. Notice what number we're distributing here. A negative 1 to both. So we get 2x minus 2, negative 1x. Negative 1 times positive 1 is negative 1. If we keep solving now, we got some like terms here that we can combine. Got some more like terms here. Looks like we get an answer of 1. Now, just like we said before, check your answer. Does 1 work? If we go back to the original problem, is 1 okay? Well, 1 plus 1 is 1, that's 2. That's okay there. 1 minus 1 is, ooh, this one equals 0. We get division by 0. So is 1 an okay answer? No. Now, in this case, we don't have another option to go with. 1 was the only answer. So in this case, this problem, we would say has no solution. There is no number you can put in for x that makes these two sides equal. This problem has no solution. Let's try another one. Number 8, we want to solve this one out. Another subtraction problem. You see some pluses and minuses here. We need to factor first. So the first step, go through factor the whole thing. So on this first one, looks like there's a greatest common factor of 3. On the second one, looks like there's a greatest common factor of 4. On the last one, there looks like there's a greatest common factor of 2. All right, now we got to figure out what's our common denominator. So all these terms we want to go through and multiply. Looks like we need to figure out what's the least common multiple of 3, 4, and 2. Looks like the first number that all those would go into would be 12. So we want to make 12 the number in front. So this needs to get multiplied by 4. This one needs to get multiplied by 3. This one needs to get multiplied by 6. So now they should all have 12 as the number. Now we got to look about these variables. Looks like some of these got an n plus 1, but this one has an middle one has an n minus 1. So we're going to have to multiply this one by an n minus 1, which means the top needs to get multiplied by n minus 1. The middle one needs an n plus 1. And the last one needs an n minus 1. Now again, if we multiplied through by our common denominator, all the denominators are gone. We need to focus on solving the numerator. So what we end up with is this. We got a minus sign. We got an equal sign, so we got to get that in there. So now it's just a lot of algebra. How do we solve this out? Probably focus on multiplying these terms together first and see what you get here. So you got 28 and this is going to be 15, 18n, and minus 1. So now it looks like we got some distributing to do. Be careful on this middle one again. It's a negative that we're distributing when we do this one. So we'll get 28n squared minus 28n minus 15n. All right, put all the like terms together. And on this one, it looks like we're going to need to move everything to the same side because we're going to have an n squared term and an n to the first power term. So if we move everything to the left side here, meaning we need to minus 18n squared and add 18n. Now this should be equal to 0. You get 10n squared minus 25n minus 15. We got to solve this out. Well, this one's a little bit harder to factor. One thing it looks like we could do here is all these terms are divisible by 5. So we could divide through by 5 to make this a little easier. So if we divide through by 5, now we got 2n squared minus 5n minus 3 equals 0. That should be a little bit easier to work with. We need to figure out what's going to multiply to 2n squared. Well, that would be 2n and n. Now we got to figure out what's going to multiply to negative 3. Well, it's either going to be 3 and negative 1 or negative 3 and positive 1. And then we'd have to figure out how that's going to multiply. So we can use guess and check method. You could do factor by grouping. Let's try guess and check and see if we can get it. Let's try, I don't know, negative 1 plus 3. So if we were to multiply these out now, if you did FOIL on this, you get 2n squared plus 3n minus 1n minus 3. Do these two middle terms add to negative 5? Oh, sorry, plus. This should be plus. Let's try that again. I didn't multiply very good. If we multiply this out, you get 2n squared using FOIL plus 6n minus 1n minus 3. These two add to 5n. Now that is close to what we got, but this is a positive 5n. I think if we then would maybe just switch the signs on these, make this one plus 1, this one minus 3, now it might work. So if we were to go through and do FOIL on this now, you'd get 2n squared minus 6n plus 1n minus 3. These two do add to negative 5. So it looks like that is how you should factor this one. Now put them both equal to 0, and you can get your answer. So one answer is 3. The other answer would be negative 1/2. Now remember, you got to check your answers. Does 3 and negative 1/2 work back on the original problem? Well, if we put 3 in here, that one looks fine. That one's not going to be 0, and that one doesn't equal 0. So 3 is a good answer. Let's check negative 1/2. If we were to put negative 0.5 in for all these, would it work? Yeah, this one was not going to equal 0. If we put negative 0.5 in here, that one's not going to equal 0. If we put negative 0.5 in, that one doesn't equal 0. So on this one, both answers work out. Both 3 and negative 1/2 are answers. All right, why don't you guys pause it again, try number 9 out, see if you can do number 9 and get that one. So try it out, get a common denominator first. You're going to need to do some factoring. All right, let's check out, see how you did. Yeah, if you went through and got the common denominator, it should be p plus 1 times p minus 1. So you got to get that denominator on all of them. And then if you solve the numerator, you should have gotten 2 answers of p equals 2 and p equals negative 1. 2 is a good answer. Negative 1 is an extraneous one. If you put negative 1 in there, it doesn't work out. All right. Where this would come up would be problems like this. You would need to solve some of these rational problems if you got to like one like number 10. Let's read through it. It says Brienne and Owen paint houses together. If Brienne can paint a particular house in 6 days and Owen can paint the same house in 5 days, how long would it take the two of them to work together? Well, you see you got some numbers here, 6 and 5, probably important to the problem. Should we just probably add them together and get the answer? Would it be 11 days that it would take them? Well, no. It shouldn't take them more time if they work together. It should actually take them less time to work together. So it's not 11. Should we just minus them? Would it only take them 1 day? Well, no, if you just kind of think about it, that seems way too fast. If it takes them 6 days and 5 days alone, 1 seems a little fast for them working together to be able to get done. How can we do this? Well, in this case, you want to figure out what can they do in 1 day. If we figure out how much of the house they can paint in 1 day, you can do it. Well, Brienne, if it takes her 6 days to paint the house, that means she can paint the house, or the amount she can do in 1 day, and we'll just call it X, would be whatever that is divided by 6 days. That's her rate. Okay, she can do 1/6 of it each day. Owen takes 5 days. So if we take Owen's rate and divide by 5, that would tell us his rate. If they work together, we're adding those together. And what they're trying to complete is 1 house. So how long would it take them to complete 1? If it said how long would it take the two of them if they work together to paint 2 houses, then we'd put a 2 here. Okay? So we just want to figure out how long it takes them to do 1. So if we can solve this problem, we should be able to do it. Well, what do we need if we are trying to add together 2 fractions? We need a common denominator. So it's just like we did on all these other problems. Get a common denominator, see what you get. So this one looks like we would need to multiply by 5, 6, and on the other side, if it doesn't have a denominator, we'd want it to be the same thing of 30. So now if we get these all, whatever you multiply on bottom, multiply to top. So our equation becomes 5x over 30 plus 6x over 30 equals 30 over 30, or 1. Well, just like before, if we times everything by 30 now, all these are gone. We just got to solve the top. So we got 11x equals 30. Divide by 11, and it looks like it would take them 30 over 11, which is the same as 2 and 8/11 days to finish it. So it takes them a little more than 2 days, not quite 3 days, but 2 and 8/11 or whatever that would come out to be as a decimal number to finish. Let's try another one where you would be asked to do something like this. It says on number 11, the ratio, remember ratios mean, from geometry, you did a bunch of those, it means like you got a fraction here. The ratio of 16 more than a number, all right, 16 more than a number, more than means adding. We don't know what the number is, let's call it n. 2, that means we're switching to the other side of the fraction now. 12 less than that number. So if we take that number and take 12 less than that, or minus 12, equals 1, 2, 3. This is another ratio. 1, 2 means we're switching to the other side of the fraction. 3. Well, on a problem like this, this is just one fraction equals another fraction, so you could cross multiply. Would work. If you want to cross multiply at this point, you can get the answer. We could also do the same thing we talked about before in these other problems, and you can figure out what's the common denominator. So we could times this by 3. So I got times the top by 3, times this by n minus 12 to get the common denominator. So this gets multiplied by n minus 12. Now if we'd multiply, these would be gone. So you solve the top. It's basically like cross multiplying. So we get 48 plus 3n equals, here we're distributing 1, so it's just going to be the same thing. Now I'll get similar terms on the same side. Divide by 2, and it looks like negative 30 is the number that makes this true. And negative 30 would work out because if we put negative 30 into this denominator, we do not get division by 0. All right, the last problems here, these are ones that are inequalities, meaning we have now less than, greater than type signs. Solve it the exact same way. Get the common denominator and solve it through. So here it looks like we need to figure out what's the least common multiple of 4, 8, and 2. All those numbers go into 8. So we'd want to times this by 2. This is already 8, times this by 4. And they all need an a, so this last one also needs to get multiplied by an a. So now if we would times all the denominators, they'd all disappear. We just got to solve the top. 2 times 1 would be 2, plus 5 is greater than, if you multiply this out, you get 4a. Now it's just solving. If we divide by 4, it looks like 7 divided by 4 is going to be about 1.75. Or it is 1.75. Now if they ask you to graph that, we'd want to graph down here. You can label this however you want to make it easier on yourself. We could go like 1, make this 1.5, 2, or something like that. So 1.75 would be right here, and it would be open circle because we don't have it or equals to. Now which way should we graph that? In this case, we cannot follow the arrow. This is saying 1.75 is greater than all the values. So this is bigger than all the answers. It should be going this way. If you want to be able to follow the arrow, write this the other way. Put a on the left. It's pointing at the a. We need to be pointing at the a. Yep, it's going to the left here. All right, why don't you pause it, try the last one. All right, let's see what you got. If you got the common denominator here, it looks like it's 15b, so you got to times this by 5, times this by 3, and this needs a b. Whatever you do the bottom, do the top. And if you solve this one out correctly, you should get that b is greater than negative 1. So when you graph it, it should look like that. All right, try out your worksheet.